Hi, my name is Nick McCarroll, and I'm a product specialist with Check Point Software Technologies. Now, today I want to talk a little bit about how Check Point can protect your entire organization from advanced and zero-day threats using our sandboxing technology called Check Point Sandblast. But before I get into that, I want to talk a little bit about the other products that Check Point has that can protect your entire organization. We have products in the mobile solution space, like our MTP or Mobile Threat Prevention product, which can protect against malicious applications on mobile devices like Android or iOS. We can provide detection against malicious wireless networks as your users are connecting to networks outside of your organization and potentially exposing their device or your corporate information to threats. We can protect the device itself by doing device integrity checks on the underlying operating system to make sure it hasn't been compromised, and we can tie all of that in to your existing mobile device management solution that you already have in place, or we can support a BYOD strategy. We can also provide a secure container called Capsule Workspace that allows your users to connect into corporate resources like email or internal websites while using their mobile device, either again through a BYOD or through a managed strategy within your organization. And we have the ability to even extend our protections right down to the individual file level with our Capsule Docs product, which can provide document encryption that allows you to access files internally or externally and send files that are encrypted to users outside your organization, and then provides a secure mechanism for them to access those files without exposing your environment to any data loss. Check Point has solutions that go everywhere from the home office right into the SMB or branch office space, and then right up, of course, to the enterprise or corporate sized environment. We have wireless or wired SMB appliances. We also have our Sandblast agent, which can provide advanced threat prevention and forensics protection to your endpoints, but I'm going to be talking a little bit more about that later on in the presentation. When you get into the software-defined data center space, Check Point has its vSec product line, which can secure cloud services like Amazon's AWS or Microsoft Azure. We have a solution for VMware vCloud, and we also have software as a service based solutions to protect things like Microsoft Office, Google Drive, or Salesforce. We also have the Check Point Cloud Firewall called Capsule Cloud, which would fall under that space as well. Now, all of these different services are tied together through a central intelligence gathering and information service called Check Point's Threat Cloud, which leverages indicators collected from Check Point sensors all over the world, from third-party feeds, from our own customers as they provide information back to Check Point, so that centralized protection and signatures can be shared amongst all of the various different products that Check Point has out on the market today. Now, Check Point is mainly known in the industry as being a firewall vendor. Check Point's next generation firewall technology is well established as the benchmark for next gen firewalls in the industry today. When you talk about a next-gen firewall, essentially you're talking about something that can, do your standard stateful-based packet inspection, but can also do things like, inspect traffic at layer 7 at the application level, can do URL filtering, can provide intrusion prevention, signatures, antivirus. We have an anti-bot technology which can detect outgoing connections to determine whether or not they're going to a malicious website, a malicious IP address, or that there is some sort of an indicator that the underlying host that is initiating the connection has been compromised. Check Point can provide identity awareness based solutions, which again is another tenet of a next gen firewall, so that you can create your policy around users and around groups instead of around network segments or IP addresses. All of the Check Point products can provide HTTPS inspection on the box so that you can look into encrypted streams and be able to determine what are the contents of that stream and whether or not it meets your corporate policy. Check Point has solutions that extend into other areas like data loss prevention. We have a DDoS protection service. We have things like our endpoint protection, which can take all of those different features and functionality of the Check Point gateway and push it down onto the endpoint itself, so that the endpoint can have your same corporate policy regardless of whether it's located in your office or outside your office. For a user who's using a laptop and who's traveling or who's taking corporate resources home, we can extend that solution with our full disk encryption technology. We have a media and port protection technology, an integrated VPN, our compliance blade, and this can all happen on a single agent on your endpoint to be able to provide you with both the maximum amount of flexibility around any one of those solutions, either augmenting your existing security infrastructure on your endpoint or providing the complete picture, the complete package, all in a lightweight solution. Now, Check Point is fairly well known in the industry for its management technology, and so our next generation security management solution, which would be Check Point R80, which also integrates things like Check Point's Smart Event or SIM technology, can provide multi-user access to your security policy. It can provide automation and orchestration through our open API, and it can provide you with the big picture view of everything that's happening in your organization from a central location to give you the maximum visibility into the threats that are affecting you today. Now, that Check Point vSec technology that can provide security in the cloud-based or the infrastructure as a service space can also be brought into the private cloud space around products like VMware NSX, Cisco's ACI, or OpenStack. Now, this vSec technology can take all of the various different security features and functionality of a physical checkpoint gateway, and it can push it into the virtual space, and it can automatically and dynamically protect your virtual environment as new machines get created, as machines move from one zone to another. Security can basically at that point become a service that gets automatically provisioned and applied as your virtual environment changes, grows, shrinks, or responds dynamically to the needs of your enterprise. Now, that's sort of Check Point in a nutshell, at a high-level view, in that Check Point has security solutions that span all of the various different aspects of your enterprise. But today, what we want to focus in on is a specific technology with Check Point, which is called Sandblast. Now, that's Check Point's zero-day protection technology. So to help demonstrate what Check Point Sandblast is, I'm going to start by telling a story. Now, let's say that we have an HR administrator who receives a resume from the outside world. Now, that's not an uncommon occurrence in most organizations. However, in this particular instance, that resume is infected with a virus. Now, we're going to show you what happens when the user opens that email virus. The user receives a .doc file that made its way through the existing security infrastructure because it's using something that leverages a zero-day exploit or an unknown attack. When the user opens up that file from the outside world, their machine is infected with a crypto virus or a ransomware style virus where, essentially at this point there's nothing much that you can do. It's going to start encrypting files on that user's machine. It's going to start reaching out to network shares and attempting to encrypt those as well too. And basically that user has now both been impacted directly in that they can't proceed with their work. The IT organization is going to need to get involved, and because of the nature of most ransomware, it's likely going to start reaching out and attempting to compromise or infect other files on the network. Now, the concept of ransomware should be familiar to most organizations. Reports show that at the end of March 2016, 93% of all phishing emails contained ransomware. The recent Verizon DBIR report showed that ransomware was the #2 spot in the category of crimeware, and that based off of their statistics, it's likely to become the #1, sometime this year or even early on into 2017. As I mentioned, once you have ransomware, you don't have too many options around what you can do to remediate from it. You will just basically have to restore the machine from a backup tape, potentially also restoring your network shares from backup, and you have to hope that the ransomware infection happened fairly close to when you caught it or when it became active, because if it had been sitting dormant on that machine for multiple days or multiple weeks, then even restoring from backup isn't going to necessarily help your organization. You'll have to come to the hard decision of whether or not you pay that ransom that's being demanded, or you accept the consequences of potentially having to roll your entire organization back multiple days or even multiple weeks to be able to find a clean backup to restore from. Now, many vendors that are currently out there on the market tell you that the solution to those types of zero-day or advanced threats is a sandboxing solution. However, traditional sandboxes also have their flaws. The traditional sandbox method is to intercept the file through whatever protocol or mechanism it's making its way into the environment, be it over a web download, over email, an FTP, or any other mechanism in which files from the outside world are making their way in, to take that file and to send it into an emulation environment or a sandboxing environment, test the file out within that environment, see if it does anything malicious to the virtual machine that you're testing it on, and then based off of whether it is or is not malicious, render a verdict to either allow the file in or to prevent the file from making its way into the environment by blocking it. Now, the big problem with the way that traditional sandboxes work is that they're highly disruptive to your users. If you're intercepting files as they're making their way into the environment and you're preventing the user from getting their file right away, even if it's an email, delaying an email by the traditional time frame that most sandboxes take to test, which would be 10 minutes or so on each individual file, can cause a huge disruption in any medium to large sized organization where users are expecting files to come through quickly, where the users are expecting to be able to download files at the speed of the network that they've been connected to, and where users are going to basically start complaining to IT anytime that process has been disrupted. So most sandboxing technology has the capability of protecting you against advanced threats, but because of the way that it's deployed and managed within the environment is actually changed or tuned to be more of a detection-only technology as opposed to a prevention technology. And when you're talking about threats like ransomware or something that steals credentials or passwords or any kind of a advanced threat that could potentially cause a lot of damage or harm to your organization, allowing that threat to come in once before you have a protection or a signature in place to stop it essentially nullifies any advantage that security technology provides to you, other than the fact that it's going to alert you after the fact that you've been compromised and that you now have a long remediation effort ahead of you to be able to stop that threat from spreading and to be able to undo the damage that it caused. Now, if we look at that exact same scenario, only this time we protect the user with the Check Point Sandblast technology, we're going to show you what it looks like when a next generation sandbox is able to offer actual security to your organization. So the first thing we're going to do is we're going to convert that doc file to a PDF using a technology we have called threat extraction. So we can take that file, we can take it as an unknown state, and we can convert it to a known state or a safe state, and then provide that safe file to the user right away. Now if the user wanted to get the original file, we provide a self-service mechanism for them to go into a web-based portal and request the original file to be downloaded. Maybe there's a macro or something attached to it. However, if we in our sandbox pick up that that file is malicious, we stop the user from being able to download it, and we alert the administrator that we detected a malicious file. Now we clean the file instantaneously, so the users get the clean file delivered to them at the speed that they would expect to be able to access their email or access their web downloads, and we then send the file away to the sandbox to be tested. Now this isn't a brand new technology to Check Point. We've been doing this for quite some time, and we've been gathering metrics around how often do users actually go and request that the original file be sent to them, and it seems to be at this point roughly about 2% of the time. So 98% of the time a cleaned file, a file that's either been converted to a PDF or a file where we've reached into the file type, extracted any threats or potential threats out of that, and then delivered the clean version to the user. 98% of the time that provides the user with all of the information they need from a file that they have downloaded from an untrusted source. Now, the other thing that we do in that particular instance is we send the file to our sandbox. And now the Check Point Sandbox is slightly different than any of the other sandboxing technologies that are out there on the market today, in that we also integrate a technology called CPU level detection. So Check Point has a traditional sandbox in which we have a technology that can open up files in a virtual environment and can run it through a barrage of different tests to try and get malware to coax itself out of that file and to try and capture any of the artifacts or any of the indicators of compromise that may be caused as a result of running that file. However, we also have the CPU level detection technology, which can actually pick up that a file is malicious before it actually gets a chance to run on that emulation environment, and then ultimately before it's able to run on the endpoint that's requested that file or that that file has been sent to. Now the way that that works is a lot of files have to exploit some sort of a vulnerability on either the application that they're delivered through, so for example Adobe through the PDF file format type, or on the underlying operating system itself, so Windows XP, Windows 7, Windows 8. You have to be able to exploit a flaw in any one of those mechanisms to be able to get shellcode to run, and then that shellcode will either put together the malware from the contents within the file itself, or it will reach out to the internet and it will attempt to pull the malware down that way. Now, when you need to create an exploit that leverages a vulnerability, you have to somehow get your shellcode to run. So the mechanisms in which you get shellcode to run are often through return-oriented or jump-oriented programming style attacks, or through some other type of memory manipulation. You are exploiting a vulnerability, which usually means a buffer overflow, but modern CPUs and modern operating systems have memory protection in place, like ASLR, to prevent you from being able to address and read directly from specific points in memory or specific points in RAM. So using techniques like ROP or JOP allows you to create your own instructions to get your shellcode to run by either assembling things like gadgets from known bits of code that exist within that particular application itself, or known instructions that you can utilize to get your shellcode to run, or by jumping back and forth to different points in memory and then leveraging those jumps to be able to assemble enough instructions to get shellcode to run. So because we can sit at the CPU level using an API that's been exposed to us, we're able to witness how the application manipulates memory as it gets run on the sandboxing system, and we're able to see whether or not a ROP or a JOP or any other kind of exploit style attack takes place prior to the malware actually making its way onto the sandbox. So modern malware is usually sandbox resistant, or it's at least evasive of most sandboxing technologies. However, we still need to get that shellcode to run. So to get that shellcode to run, an exploit needs to take place, and if you can pick it up at the exploit level, then you can stop it within the first few seconds of you even attempting to execute the file, and you can also stop it before you get to the stage where it could be any one of millions of different variants of malware. Now, malware authors are able to change and manipulate the underlying code to their malware multiple times, maybe even each time the malware runs, so that traditional signature-based detection isn't able to pick up on it. Traditional heuristic-based detection isn't able to pick up on it. A lot of technology that's out there on the market today that proclaims itself to being advanced threat detection is actually using an algorithm to pick up on suspicious behavior. Now, that algorithm is, again, something that malware authors can learn about, can create their malware to evade or to, get around that type of technology. However, that exploit still needs to take place most of the time to get the malware to run, and very few malware authors are able to come up with and create new exploit techniques on a regular basis, because there's only so many ways in which you can manipulate memory to get shellcode to run. So the Check Point Sandblast CPU level detection technology is able to pick up on that, and we're able to determine whether or not an exploit takes place prior to the malware running on the sandbox. So we've talked about how you can deploy the Check Point Sandblast technology within your environment, but we've only gone into a little bit of detail around the cloud. Now, there is the Sandblast Cloud solution, which is a location that Check Point can provide where you can send files for emulation without needing any infrastructure to be installed within your organization. But we also need to protect cloud services as well too. So IaaS, or infrastructure as a service, like Amazon or Microsoft's Azure. We also have software as a service that needs to be protected, like Microsoft's Office 365. Now, from an infrastructure perspective, I've already talked a little bit about Check Point VSec, but we can't go too much into detail around that today because the focus is going to be on our sandboxing technology. So what we want to talk about is how you can protect cloud-based solutions like Office 365 with the Check Point Sandblast Cloud. We can do this transparently to the user. We can do this seamlessly from a API perspective, where we're communicating from a cloud-to-cloud based solution, and we have already extended this directly into Microsoft's Office 365 based services. So the way it works is files are sent to a user who has an Office 365 account. We automatically intercept those files, place them in a hidden folder, send them from Office to our cloud so that they can be analyzed, so that if there are threats, that those threats can be extracted. We send the file back to the user, and if it is malicious, that file is blocked and the administrator is alerted. The user receives the file that they would be expecting to receive, and they receive the protection that they would expect if they were behind the corporate security services. So that was what it looks like from an architecture perspective, but what does that actually look like in real life? So if I take a cloud-based email service here, my Walla Mail account, and I send a malicious email to my Office 365 based target. So this is an Excel file that has a malicious macro attached to it. Now I send that from one service to another. I jump over to my Office 365 account, the email arrives, and we intercept it right away through the API that Microsoft has provided, and then we return the email once we've had a chance to clean it. So that cleaning process doesn't take very long, only a second or so. The user gets an email right away, but when they try and open up that attachment, we've in this instance blocked the malicious file, let the user know that that attachment was deleted by Check Point Sandblast solution and that they're protected. On the administrator side, there is a cloud-based dashboard where they can go and they can see all the logs that have been generated from us protecting the Office 365 service. If I filter all my logs on the last hour, I can see that email that I just sent through. There's the threat prevention log, which is showing me that the file was sent from one user to another and that we picked up on the fact that it was malicious. I also have my logs showing me what happened when we ran the file in the sandbox. So what was the indicators of compromise as we ran it through the sandbox, what malicious activity occurred, what processes were affected, what registry entries were affected. We took screenshots along the way while it was running in our cloud service, and we put that all into a report that the administrator can see through the cloud portal. So if you're just protecting an Office 365 service, you can actually do that through a completely cloud-based solution. You don't need any Check Point hardware on premise to be able to offer that protection. Now, if you do have Check Point hardware on premise, those logs from the cloud service can be securely downloaded into your local environment, and they can become part of the overall security logs that you already capture for the rest of your corporation, for the rest of your organization. So again, a hybrid model can be taken here where there's the cloud-based solution and potentially an on-premise solution, and both of them can work in conjunction with each other, or we can do it as a pure cloud-based solution where you don't need any hardware on premise at all. Talked about what the user experiences when they're protected with Check Point Sandblast technology, but what about the security administrator? Now, it's their job to secure your entire organization, and if this technology were difficult to manage or difficult to integrate into the rest of your security infrastructure, then it wouldn't be very valuable to the organization. However, because the Sandblast technology is integrated into all of the other security components that Check Point provides today, the administrator is able to see that big picture of all of the important events that are happening and what they need to be paying attention to. So things like their application events, their URL filtering events, or any of the threat prevention events can all be captured and gathered in through a central location through, for example, the Check Point SIM, which is called Smart Event. Now in your SIM, you're able to see the last 200 events, the most popular sources, the top events by event type. You're able to see all the important security events as they occurred over time, and in any one of those events you can open them up and drill down into who the file was sent to. In this case, user1 at unknown300.com received a malicious file from joe.smith at unknown300.com. We detected that it was malicious. We prevented the file from getting through. Here are some reports that you can access to provide additional information around that. And then if we get even further into the details of that particular log, we can see criteria around the file that we emulated, around the verdict that we came to when we tested the file out, and then more details around the protection that caught that attack. Now, from there you can even drill down into that same report that we saw when we were reviewing our logs in the cloud-based portal, and we can scroll down and we can see all of the various different indicators of compromise that we picked up. The administrator can even, if they want to, download the malicious file so that they can bring it into a lab environment, or they can bring it into other sandboxing technology, and they can deconstruct the file and figure out what it was attempting to do when it made its way to your end user. Now, across your whole organization, not only are you able to see the threats and see all of the events, but you're also able to see all of the different gateways that you have, or all of the different inspection points. So you're able to centrally manage your gateways across your various different data centers, across your remote offices or your small offices. You're able to centrally manage your policy across all of these different gateways. you're able to pull into the profile or the policy that dictates how these gateways inspect for threats, what types of threat inspection technologies are enabled. So for example, the anti-bot and antivirus technology would be signature based, either looking at incoming or outgoing files and trying to determine whether there was a match on the type of file, whether there was a match on the domain or on a match on the IP address that the computers were attempting to connect to. Then the threat emulation and the threat extraction technology, which make up the Check Point Sandblast solution, those can be enabled or disabled on gateways depending on whether it's appropriate for those gateways to be doing those types of inspections. We can pull up common statistics across our organization around the infection incidents and the known viruses that we're seeing. We can drill down into any one of those sections and pull up the logs around it. We can also see what source of country is sending us malware, or what are we detecting as a malware source within our organization. And then we can dive even deeper into both the logs that cover off our entire environment, our entire organization. So we can pull logs across multiple gateways into a central location, and from there we can do searches based off of either a log file type or the type of inspection that was detected. We can search across users, so as a user moves from environment to environment, because of identity awareness, we always know who they are, so we can do searches and queries based off of that individual user. We can do searches based off of that geographic location or that gateway, and we can dive in and see exactly what's happening. Now, the Check Point Smart Log technology is an index and cached log technology. So when we provide you with a Google-like search query, you're able to search your logs near instantaneously and parse millions upon millions upon millions of log records with very little lag or delay or slowdown as it scans across multiple different log sources. And then we can also go in and see the health of our various different gateways or inspection points across our network using a tool called Smart View Monitor, which allows us to go in and see the status on any of our gateways, pull up reports around our traffic, around top services, around top destinations, any QoS rules that we might have. We can see what version the various different gateways are running, and we can plan and provision around upgrades, and we can plan and provision around patching using our integrated tool suite. So we've covered off how Check Point Sandblast technology can not only protect the user, but can provide more protection and more visibility to the security administrator, which ultimately simplifies the day-to-day operations and reduces the complexity needed from deploying advanced security solutions within the environment. In many environments today, point products are being purchased and being deployed to take care of a specific use case or a specific type of threat. And for every point product that you deploy within your organization, that's something that now needs to be managed separately, that needs to be tuned separately, patched separately. You need to be trained on the best way to administer and the best way to implement these tools. And as these tools grow and change and morph, then the organization and the employees who are responsible for administering these tools have to also grow with those tool suites. So over time, as you have a limited amount of availability to actually spend time digging deep and becoming an expert in each one of these tools, they're becoming less and less effective within your environment because they're no longer providing you with the protection that they are capable of providing due to the complexity of managing and maintaining all of these disparate tool suites. So we've covered off our protections around the network space, but what about on the endpoint? So I already spoke a little bit about how Check Point can provide our Sandblast agent technology on the endpoint, but let's go into some detail around what that actually means. So the Sandblast agent technology takes that same threat prevention technology that works from a threat extraction and a threat emulation perspective, and it moves it down onto the endpoint in a lightweight client. Now, to augment the endpoint and to provide additional layers of protection and containment, we also add in our forensics blade and our anti-bot blade. So those four different security protections, threat emulation, threat extraction, anti-bot, and forensics, are what make up the Sandblast agent technology. So the CPU level detection is there. Again, it can be running in the cloud-based service, or it can be running on a local threat appliance that is providing the whole corporation with an emulation environment on premise. And then that threat extraction technology exists on the agent as well as on the Sandblast appliances. So regardless of where the user is located, be it within the corporate environment, or if they're traveling, or if they're outside your corporate environment, they're always going to be protected. As well, we're going to be inspecting files regardless of the mechanism in which they make their way onto the endpoint. So when they're sitting behind your corporate environment, you may already be scanning and looking at files that are coming through a network file share, through a web download, through email. However, you're not able to capture any of the files that are brought in through, say, a removable USB storage device, or if the user takes their laptop home and connects it to a home network over that particular network. So Sandblast Agent is sitting and it's inspecting that traffic regardless of the mechanism in which it's making its way onto the endpoint itself. Now, we're also extending the Sandblast technology by adding a browser plugin that sits on the endpoint and provides a mechanism in which we're also inspecting that technology, or we're also using that technology to inspect files. So the browser agent sits resident on the browser. As files are being downloaded, we're intercepting the files, we're sending them away to be cleaned, and the clean version delivered to the user. And we're also providing that same self-service mechanism in which the user can go and retrieve the original file if we've determined that it is benign and that there is no malicious content within the file itself. Now, because we have that browser agent sitting there and inspecting files, what better place to then also integrate additional layers of security? So we have our zero phish technology, which can be used to prevent against phishing style attacks. Now, at the beginning of this presentation, we talked a little bit about how phishing attacks are a very common mechanism in which ransomware is now making its way onto the environment. So the zero phish technology works by inspecting the websites that the user is browsing to and determining whether or not those websites are malicious and whether or not those websites are who they say they are. So the way that works is, say, if a user attempts to go to a site like PayPal and that PayPal site is being spoofed, we'll automatically redirect them to a portal page that lets them know that their credentials could be stolen or that they are being phished. And then if they go back to that fake PayPal site or back to that fake phishing site, then the form fields where they're requesting a username and a password will actually be blocked so that the user is not able to compromise themselves or compromise the security of that endpoint. So we also, on the Sandblast agent, have a security product called our Forensics Blade, which provides an interactive attack summary to the security administrator based on files as they get executed on that endpoint, if those files happen to have made their way onto the endpoint without being caught by any of the other security technology in place. Now, how does that work? Well, essentially we're sitting and we're capturing all the network registry file changes for everything that's happening on that endpoint in a protected container. And now if a trigger gets picked up, so say an antivirus alert gets detected, or we detect a file in our sandbox, then we take all of the forensic information that we captured around that event and we send it to the log server. Now within the log server, you're able to open up a forensic report and see things like, okay, if we triggered on this OEM7EC2.exe file, where did that file come from? Well, it looks like that file came from the handle.temp process that was started in the temp directory, which was created by chrome.exe when it went to that aatagiigar.com website, which was obviously an infected website. So we're able to see the whole attack chain, identify the origin really quickly, see what exploit code was dropped or launched, see if any persistence was created around scheduled execution time, see what the malware was, and then dig into any one of those bits and pieces of the attack to see what was compromised within the organization. Now, staying one step ahead is Check Point's corporate motto, and part of the ability for us to stay one step ahead is to be able to provide a way that we can see what types of attacks are making their way into the organization, detect those attacks if we are able to, and stop them before they make their way onto the endpoint, but then also have that last line of defense on the endpoint itself to prevent any further damage from happening and to give you the ability to remediate attacks if they do make their way through. Now, in many EDR-based solutions that are on the market today, a forensic report is essentially assembled by a forensic investigator. So a lot of vendors will give you the tools that you require to put together a forensic case, but those cases have to be manually assembled and pieced together one by one while a forensic investigator goes through all of the evidence that the tool has collected to come up with a story of, how did this malware enter my system, what needs to be done to remediate it, what is my business impact, and that will all be based off of the suspicious activity. Now, the difference between those tools and the Check Point forensic tool is that we do all of that automatically for you, so that all the security administrator has to do is review the report, and they not only get the big picture automatically of everything that has happened, but they can also have automatic remediation take place. So we can provide a breakdown of the suspicious activity over time. We can see all of the things that were associated with that attack. Part of the reason for that is that we've not only captured everything around the attack, because we have that forensic blade constantly running on the endpoint, but then we're able to make the correlation between all of the various different events that took place on that system and see whether or not those events were tied in any way to the attack, so that we know exactly what damage was done. Now, we can provide you with a graphical and interactive breakdown of the incident by going into the incident details of the attack, and we can see how all of the various different pieces of the attack are connected to each other. So what spawned what process, what task was created as a result, what commands were run. We can go into details around what network operations were run as a result. So did this attack attempt to communicate laterally within my environment? Did it attempt to call home to to receive additional instructions or pull down additional malware onto the endpoint or onto the system? All of that information is very visibly presented to the security administrator so that they're able to see the big picture of that attack. Now, of course, the final step is, it's great to be able to pull down all of the details around an attack, but ultimately the end goal is securing the endpoint and securing the organization. So because this isn't a point product, it is a component of a much larger suite of tools that Check Point can provide, we can tie the forensic reports into things like our compliance blade, or we can tie it into things like our firewall blade, so that if malware is detected on an endpoint, and then that malware runs and then is picked up right away and is prevented or is stopped, we can automatically do things like indicate that the existence of malware on an endpoint, even if it has been remediated or removed, is cause for concern, and therefore that machine has moved out of compliance, and somebody needs to inspect that report and needs to determine whether or not there's any cause for concern beyond any of the automatic remediation that's taken place. The compliance blade can provide that. It can send instructions to the firewall blade and say lock down all of the ports and all of the connections that that machine can make to any of the servers within my corporate environment, or any of the other resources that I have to try and contain any potential threats that may still exist on that endpoint until the security administrator has verified it. Now this can all take place automatically, so that one event triggers another, triggers another, triggers another, and ultimately you have this automatic remediation process in place, which means that the security administrator doesn't need to be concerned about doing all of these steps manually. They don't need to rush out and pull the Ethernet cord or turn the wireless access point off on an endpoint that's been compromised to prevent it from potentially infecting the rest of the machines on the network. The sheer existence of the fact that we've picked up that this machine has been compromised means that we can automatically remediate, and we can automatically start moving this machine into a place where it's protected from further infection, but also we're protecting the rest of our network potentially from that machine. So the focus of the Check Point Sandblast technology is first and foremost around prevention. So we put all of these mechanisms in place to prevent files from infecting your machines, to prevent files from getting into your environment in the first place. Now, the second component, the inspection component, provides us with all of the visibility that you would need as the security administrator to see what threats are making their way, to the edge of your network or to your users, either through your corporate-based security protection or the protections that you've extended into the cloud, as well any threat that has happened to make its way right down to your endpoint itself and potentially even run or executed. Then from that point, giving you automatic remediation so that you can automatically start removing threats as they're detected on the endpoint itself, or you can automatically remediate threats as they're seen on the edge of your network, and then taking all of those advanced, those zero-day based threat prevention technologies and integrating it into the rest of your security architecture. So that outlines all of the capabilities of the Check Point Sandblast technology. We talked about our network-based protection in terms of our gateway and cloud service or our local appliance. We talked about our Sandblast agent, which is the security protection down on the endpoint with the integration of our forensics capabilities. And we talked about our Sandblast cloud, which can not only provide an environment in which the files can be emulated, but also can provide a direct cloud-to-cloud based connection with software as a service vendors like Microsoft's Office 365 product, and provide a automatic way to secure your users as you move more and more of your corporate resources into the cloud. So thank you very much for listening to me today and for going through this presentation with me. If you have any additional questions around how the Check Point Sandblast technology can protect your environment, please reach out to your local Check Point representative or to your Check Point partner, and they will be able to connect you with either the right person or provide you with any additional information. Thank you very much.